So we're looking at questions 7, 8, and 9 of the problem package. The very first one with the ant on the front, and we're going to start with question number 7, where it says Kyle is flying a helicopter when he drops a bag. When the bag has fallen 2 seconds, what is the bag's velocity? So now it doesn't really come out and say it, but the helicopter's going straight up. Kyle and a helicopter. Question 7, as I've pointed out a few times now, it's question 7, the problem package. Peyton, do you remember when I stood over here and I went like this and I said the problem package with the ant on the front, and then I repeated it. Alrighty, so the helicopter actually no, the helicopter is hovering in this one, I think. It doesn't say whether it's going up or down. All it says is that the bag has fallen for 2 seconds. What is the bag's velocity? Okay, so the helicopter is stationary. It's not rising or falling. So we know that the bag has fallen for 2 seconds. We know the acceleration is minus 9.8. My time, 2 seconds. What is the bag's velocity? So you would write something like A equals delta V over delta T. Minus 9.8 is delta V over 2. The change in velocity is minus 19.6 meters per second. And because the initial velocity is 0, it doesn't come right out and say that, but it doesn't say that it's rising or falling. So you have to assume that the initial velocity is 0. Therefore, the final velocity is minus 19.6. Right? Like, that's pretty straightforward, I think. Is that a little too fast? Because that's all kind of review. That's kind of pretty straightforward, right? The acceleration is minus 9.8. The time is 2 seconds. A equals delta V over delta T. Minus 9.8 is delta V over 2. 2 times 9.8? 19.6, right? So the change in velocity is 19.6. So you would have something like delta V is VF minus VI. Minus 19.6 is final velocity minus 0. So what happens with the minus 0? Disappears. So minus 19.6 is the final velocity. That's all I did there, right? Right? That's just part A. What is the bag's velocity? How far has the bag fallen? When you're asked for how far, you need to find average. Before you can find how far, you have to find average. 0 plus minus 19.6 all over 2. What's the average velocity? Minus 9.8 meters per second. V bar equals D over T. Oh, not minus 19. Minus, once again, 9.8. D over how long? 2 seconds. Oh, I'm multiplying by 2 again. How far did the bag fall? 19.6 meters. Okay? No, it's not very high. No. Okay, so that is pretty sort of straightforward. Now, in the next one, Kyle is flying the same helicopter, but this time it's rising 5 meters per second when he releases the bag. So is the bag also rising at 5 meters per second? Absolutely. After 2 seconds, what is the bag's velocity? How far has the bag fallen? And how far below the helicopter is the bag? It's going to be almost identical. Acceleration is minus 9.8. The time, once again, still 2 seconds, right? So A equals delta V over delta T. Minus 19.6 meters per second. Now, is the final velocity minus 19.6 meters per second again in this one? Why not? because it's going up. The initial velocity of the bag is +5. Do we need to worry about plus and negative signs in this one? Yes, absolutely. Excuse me. Okay? Absolutely, because the helicopter in the bag is rising at +5 meters per second, and the acceleration is down at minus. Now, delta V is VF minus VI, so minus 19.6, final velocity, minus 5. Keelan says that the initial velocity of the bag is 10 because it's over 2 seconds. Is that what you're saying? It's rising at 5 meters per second. It sort of implies that it's a constant, right? Yes. Yeah. Will this be on Schoology? Absolutely. So yes, no, it's a constant 5. Good thought, just right. Well, good that you're thinking, right? So the minus 5 is here. When it goes to the other side, it becomes +5, and so I've got minus 19.6 plus 5. And so what is my final velocity? Minus 14.6. So the bag is falling after 2 seconds, but initially, what is that bag or whatever it is, that ball or whatever he's throwing out, what does it do? If you're standing on the ground, the helicopter's rising, you would actually see the ball or the bag or whatever it is actually doing what? Going up and then coming down. You would actually see it going up and then down. You might not recognize it because you would see it. You would actually see it. Would you see it? No, I mean if you're on the ground watching. If you focused right on the ball, you might. But what would happen is, as soon as he released it, the helicopter would keep rising, but the ball would do what? Immediately start to slow down, right? And you would see that separation.
How long?
Not very long, no. Not very long before it would start falling, right? Yeah. It'd be about a half a second, because that's 5 meters per second, and gravity's about minus 10. It'd be about a half a second. Okay, so the next part is, what is the bag's velocity? That is your answer. Part B, how far has the bag fallen? Well, again, you have to go average. I can tell by the way we're discussing this that nobody actually did this question. What is the average? Did someone do it? Yeah? The initial is 5. What's the final? Minus 14.6 all over 2. And so you get an average of, oh, now I'm going to have to actually get a calculator out. 5 plus 14.6 negative, and divide that by 2, and you get an average velocity of minus 4.8. Then you go V bar is equal to D over T, average velocity of minus 4.8, D over 2. It would actually fall that times 2, right? It would fall 9.6 meters. But there's a part C. How far below the helicopter is the bag? Remember that the helicopter's doing what? Continuing to go up. The bag is falling. The bag has fallen 9.6 meters from where it was released. How far has the helicopter gone? V bar equals D over T. It's traveling at not 2. It's traveling at a constant 5 for 2 seconds. The helicopter rises 10 meters. And so my total distance between them now, is it 10 minus 9.6? It's just 9.6, because the minus just means that what? That it's down. So it's actually 10 plus a 9.6, or it's 19.6 meters apart. Isn't that odd that the helicopter and the bag are 19.6 meters apart? What happened in the very first one? The bag and the helicopter were 19.6 meters apart. Is that coincidence, do you think? How could we tell if it's coincidence? What could we change to check it? We could change the speed of the helicopter. We could change the total time. We could do lots of those things, right? I'll leave that to your own curiosity to figure out. What about number 9? This time, the helicopter is descending at 5 meters per second. I wonder if this will cause the bag to be more or less or the same as 19.6. How many people did number 9 in the problem pack? A few? Okay, so those of you that haven't, you should go ahead and do number 9. I'll give you about 5 minutes. It is identical with the exception that the helicopter is no longer rising at 5 meters per second. It's falling. And so what change do you make? You change that to a negative right there. I'll leave this up for you too. All right, so it's exactly the same question, right? This time the helicopter is descending at 5 meters per second after 2 seconds. Is this part going to be any different here? Exactly the same. The change in velocity is going to be exactly the same. The only difference here is instead of a positive, that becomes -5, which makes that -5. So I really have -5. I have a +5 on this side, which when I go to the other side becomes -5. And so what do I get right here? Minus 24.6. So the bag or the ball or whatever this is being dropped is actually traveling faster than before. How come? Because it had an initial velocity down anyways. I make this one small change in here. Minus 24.6. Now my average goes considerably in the negative spot. So that's going to be minus 19.6, right? Is the average? Is it not? 5 minus 24.6. Oh, this is a negative, right. Good eye. Okay, so that's going to be minus 29.6 divided by 2, right? Okay. Which is 14.8. Right? So put 14.8 in there. This is negative, right? Times by 2 is what we just had, right? That 29.6. Okay, so the bag falls minus 29.6. This is a negative. That's minus 10. The helicopter drops 10. The bag drops 29.6. How far apart are they? Right? The helicopter goes down 10. The bag goes down 29.6. How far apart are they? 19.6. Again. What's up with that? Interesting, isn't it? The only thing that you could do to make it not 19.6 would be to do what? No. Change the time. Well, you could change gravity, I suppose, right? If the time were 3 seconds, would it change? Yes, because it would be for farther. But if you were to do 3 seconds at hovering, 3 seconds rising, or 3 seconds falling, would they still be all three the same? Yes, they would. Yes, they would. Okay? It's not really magic. Are there any other problems that you think as a group we should look at? Alrighty, so here's the outline that I gave you at the start. So let's just go through this, and you can, if you've got this right in front of you, you can make some notes right on there if you want. If you want to do it on your phone like Joey's doing, you could do that as well. Students are to define the gravitational force constant G as a force per unit mass in newtons per kilogram. In other words, you should know that gravity is measured in newtons per kilogram. And the weight as Fw equals mg. The acceleration due to gravity is derived from Newton's laws and determined in the laboratory. Students describe the normal force in terms of the mutual attraction of masses and draw simple free bar diagrams. The student will be able to. Yeah. You have it right here. You should. I handed it out at the start of the unit. If you use the rings, it should be there at the start of the unit. You need to define the gravitational field qualitatively as the region of space around a mass where another point mass experiences a force. That's the definition of a gravitational field. It is the region of space around a mass where another point mass experiences a force. You need to be able to diagram the Earth's gravitational field using lines of force. In other words, can you draw this picture? Ooh, that's a tough one. Did I draw a good circle? Thank you, Steve. You should also know that the gravitational field is stronger where the lines are closer together and weaker where it's further apart. And you should also have a general understanding of the inverse square law, which says that if you're twice as far, then the field strength is 1/4. You should be able to define the gravitational field quantitatively as a force per unit mass. In other words, have a very good understanding of it being in newtons per kilogram. If I say an object has a mass of 10 kilograms, how much gravitational force is on it? 10 times 9.8, 198 newtons. You need to be able to compare and contrast the terms mass and weight, which means, do you know that mass is the amount of stuff and weight is the gravitational force? Could be, or I could ask for an explanation of some kind. Describe qualitatively and quantitatively apparent weight changes in vertically acceleration systems. In other words, do you understand how the person's weight changes as the helicopter or the elevator accelerates at the bottom, slows down at the top, and then sort of comes back down? Do you understand the weight differences? And can you do problems like that? We'll find out tomorrow. Can you derive the acceleration due to gravity from free fall and Newton's laws? I didn't really do too much of that. I wouldn't expect you to do that on a test. Did you perform an experiment to calculate G near the surface of the Earth? You did on a ramp. Is that going to be tested on a test? No. Can you solve free fall problems? Can you solve free fall problems? Now, obviously, there's going to be lots of different free fall problems. Like Kyle and the helicopter. Can you describe terminal velocity qualitatively and quantitatively? If I ask you what does terminal velocity mean, you have to be able to describe that. It's the maximum speed that you fall at, right? Why is there a terminal velocity? Air resistance. Would you understand if I asked you a question about terminal velocity, say on Earth as compared to Mars, that has a different density of atmosphere? What would it be? Good point, yeah. I'd have to give you numbers, wouldn't I? There is no formula. It's just when the frictional force matches the weight force, right? Terminal velocity occurs when the weight force is equal to the friction force, right? Yeah. Can you define the coefficient of friction as the ratio of force of friction and the normal force? Do you know that mu equals FF over Fn? And do you understand that mu remains the same, and if the weight increases and the normal force increases, then therefore the friction force must also increase? No. It's not a regular M, it's a U. It's a U? Well, just make a U and then do that. Ooh. Distinguish between static and kinetic friction. Static friction is, of course, at the start. Kinetic friction is as it's moving. And generally, kinetic friction is less. But it can be equal. Right? Can you compare the effects of the normal force materials involved, surface area, and speed on the force of friction? If I say there's a change of this and a change of that, what happens to friction? If you add more weight, what happens to friction? If you add more surface area, what happens to friction? Yes. Can you solve problems like the ones we did late last week with coefficient of friction for objects in a horizontal surface? So in other words, if I give you an object like this and I say that there's an applied force of, oh, I don't know, maybe 10 newtons, and mu is 0.1, can you determine the net force? If I give you the mass, right? If I give you the net force, and can you give me acceleration, and can you give me final velocity, and can you give me distance traveled? Randy? No. Where you have two equations and two unknowns, and you have to make them equal to each other. Although you will be expected to be able to do that in grade 12. Yeah. I think that's about it. Yeah, that's it. Okay, so I'm going to give you the remainder of the period. You've got about 22 minutes to work on your cheat sheet now that you've seen that. Make sure you're ready. Good luck.